Greetings and welcome to the Introduction to Astronomy. In this episode of New Discoveries in Astronomy, we will explore how astronomers are using machine learning to take a fresh look at one of the biggest mysteries in modern astrophysics, a mysterious glow of gamma rays surrounding the center of our Milky Way that may still be linked to dark matter. So, let's get started. How can astronomers determine the source of a signal when two completely different explanations produce almost the same observations? Near the center of our galaxy lies a broad glow of high-energy gamma rays known as the galactic center excess. For more than a decade, astronomers have debated what creates this unusual emission. Could it come from thousands of rapidly spinning neutron stars? Or could it be one of the first indirect signs of dark matter? A new study doesn't answer that question, but it changes how scientists evaluate the evidence. The center of the Milky Way is one of the busiest regions in the entire sky. Stars, gas clouds, black holes, and energetic particles all produce gamma rays. Separating one source from another is extremely challenging. For years, one leading explanation suggested that the glow comes from thousands of unresolved millisecond pulsars. These are rapidly rotating neutron stars that emit beams of high-energy radiation. Another possibility is far more intriguing. Some theories predict that dark matter particles could occasionally collide and annihilate each other, producing gamma rays that spread outward from the center of the galaxy. Both ideas predict remarkably similar observations. That makes distinguishing between them extraordinarily difficult. Previous studies focused mainly on where the gamma rays appeared in the sky. This new research asked a different question. What if the energy of every detected gamma ray photon also contains important information? To investigate, researchers trained a machine learning system using more than 1 million simulated observations. The AI learned to analyze both the spatial distribution of the gamma rays and the energy of individual photons at the same time. By combining these two measurements, the model extracted patterns that earlier statistical methods could not easily recognize. The results do not prove that dark matter is responsible for the galactic center excess, but they do challenge one of the strongest arguments against it. If the glow is produced by pulsars, the new analysis suggests they would have to be extraordinarily faint. In fact, researchers estimate that more than 35,000 pulsars might be required to explain the signal. That's far more than many previous models assumed. Instead of ruling out dark matter, the new analysis concludes that it remains a scientifically credible explanation. One of the strengths of science is that conclusions change when better methods become available. In this case, the researchers did not collect new observations. Instead, they extracted more information from the data astronomers already had. Machine learning did not solve the mystery. It helped scientists ask better questions about the evidence. That approach may prove valuable in many other areas of astronomy where different physical models produce nearly identical observations. This discovery reminds us that scientific progress is not always about finding new data. Sometimes it comes from finding new ways to interpret existing observations. By combining artificial intelligence with careful physical modeling, astronomers are learning to recognize subtle patterns that were previously hidden. Whether the mysterious glow ultimately comes from pulsars, dark matter, or something entirely unexpected, Each new analysis brings us closer to understanding one of the universe's greatest mysteries. So that concludes our discussion on, is the Milky Way's gamma ray glow really dark matter? We'll be back again next time for another new discovery in astronomy. So until then, have a great day everyone, and I will see you in class.